Okay, welcome back. So in this third and final video, I will show you how to translate the real timeline into the nominal timeline. So, we're real timeline adjusts everything for inflation. So we solve for that first. But of course, as time progresses, as we make our third and fourth and fifth and sixth payments, and as we, of course, once we start making withdrawals for retirement, the value of a dollar, given since the average inflation rate in our example is 2.5%, the value of the dollar is going to be falling. It's going to be changing, right? So even though we're making a real deposit of a certain amount each year, our because in order to counteract inflation, we're actually going to have to deposit more and more each year into our savings account in order to reach our retirement goal in nominal terms. Okay. And then additionally, we are going to need, we're going to need to, once we make our withdrawals, we're going to need to make higher and higher withdrawals in order to counteract the effects of inflation. Okay, so one thing we can start off doing is looking at the nominal bequest, right? That we're going to need to that we'll end up having once we pass away and leave a bequest to our children. So we'll click this cell here. We'll do equal sign, and basically we just want to index this payment here, $25,000, by inflation, by the inflation rate 2.5% over a 70-year period. So we can just take this 25,000 times open parentheses 1 plus, well, the inflation rate is 2.5%, so that's cell C2. So I'll just do cell C2. All right, C2, close parentheses, raise it to the, 70th power. And we see that, we should be leaving a nominal bequest of $140,802.57 by the time we pass away, right? So basically, at this current rate of 2.5%, right? When we deposit, when we leave our bequests, basically $25,000 today is going to be the equivalent of $140,802.57 in 70 years. Okay. Okay, and we can actually go ahead and do the same thing for this nominal retirement, right? We can just, but of course this is only over 40 years, so we can just adjust this times. So take our real retirement needed and index it, that is, to the inflation rate over a 40-year period. So that's this real retirement times 1 plus the real interest, the inflation rate, so that's C2, and then raise it to 40. Close parentheses. Okay. All right. So that shows, assuming I did everything right, hold on. So that shows that, $897,960.56, by our 70th year, it's going to have the same purchasing power as $2.4 million. So that's how much we're going to actually need in nominal terms, is $2.4 million. Did I do this right? Hold on. Yeah, I did it right. Sorry. My bad. Oops. Okay. Now, what we can do, now we can index all of these payments, right? All of these payments and withdrawals using inflation, okay? And we can do that by simply, we'll start off with the first one, right? We'll take this first one, cell C, our first real deposit, which is in cell D13, and we'll multiply it by 1, open parentheses, 1, plus the inflation rate. Close parentheses. And this time what we're going to use is we're actually not going to put a number per se for our power. We're just going to put in the cell right above it, the number in the cell right above it, which denotes the, the year, right, in which we'll make our payments. So we'll put that, close parentheses, and then press enter. And what we see is that after 1 year, we'll actually need to deposit $8,170.66. So this is actually how much we'll actually need to deposit once we've accounted for inflation. Okay. Now remember, I need to put dollar signs in front. Shame on me. C2, right? Before the C and after the C in C2. So that'll keep it constant. Right? And then I'll just drag this across. And I can just drag it all the way. Right? Because although the real payment is changing, right, the inflation rate and the numbers, the above time numbers are not changing, right? So we can still just keep it like that. So that means in your first year of retirement, although you're withdrawing an amount of money that has a purchasing power of $54,000 in today's dollars, right? What you'll actually be withdrawing is $148,618.28. Okay, and then that means by the end of your last year, you should have $304,133.55 in as a retirement withdrawal. Okay, now of course your initial wealth. Let's go ahead and calculate the nominal wealth. Your initial nominal wealth is just going to equal your initial real wealth, right? But then of course after the first year, you'll have a wealth of $12,000. Now in nominal terms, this wealth is actually going to grow not by the real interest rate, but by the nominal interest rate of 7%. So that'll be 1 plus, so C20 times 1 plus the nominal interest rate, which is C1. So I'll do $$C$1, close parentheses. And now, since we're in the pre-retirement period where you're making deposits towards your wealth, we'll just go ahead and click the first payment, the first nominal payment you're going to make. And so that by the end of your first year in saving for retirement, you should have a wealth of $21,010.66. So slightly more than your wealth after the first payment. And that's because, we're going to be, some of this is accounting for inflation. So now once I do that, I can just drag this all the way over. Oops. And sometimes you might get this little thing right here, basically just of hashtags. You can just, here, let me do that again. If you get that, like here, you can just go up to, like, highlight these and just right-click the side. I think it's usually the left. Oops, no, didn't mean to do that. There you go. One of the middle ones, and it'll double-click one of the, right on the line between two cells. So, like, right here, I can just highlight all these. Basically, the number's just too big for it to, so that basically means the cells have to be expanded. Dang, it says a lot of them. It's when it gets those hashtags, it's just telling you to expand the cells, right? And I guess one right here, I can do that. All right. So notice if you've done everything right, then this very last, nominal wealth, right? Because the retirement wealth is going to have a different formula, you should stop for the nominal wealth at year 40. But to know you've done it right, this nominal wealth here, right, at year 40 should equal the nominal retirement needed, okay? And then once we get here, right, we can just then, we can look at the drawdown, right, the nominal drawdown of our retirement. So basically we'll do this, our wealth, oops, hold on, equal sign, our wealth, why did I do that? Our wealth times 1 plus the nominal interest rate, so that's, again, C1, so we want to do $C, $1, close parentheses, and then, of course, we want to subtract the nominal withdrawal, and that should mean after the first year of retirement, we should have a total wealth of $2,431,238.83, and now we can do that. We can just drag it over. This time you only need to do it once, right? That's because we're using this cell as opposed to this cell, right? And now, right? Notice that in the very last year, your wealth should equal the nominal bequest, right? So that's how you know you've done that one right. Okay. All right. So that'll do it for this one, and you'll hear from me again. All right. Bye.